Okay, let's work on making an animation using equations, computer math to make an object move on the screen. And it's one of the great things about GlowScript is you can make things in three-dimensional representation and move them around. Okay, so log in however you set up to log in before. And we want a new trinket using GlowScript. Using over on the left, using Python. So to be able to see something to move, we need to make an object on the screen. So you can go along with this, stop the video periodically and try things out. But the most basic command is type the name of the object you want to create. And then open close parentheses. Later, inside the parentheses, we can put code that will vary some of the attributes of this object. But for now, we'll just create a sphere. And let's give it a name. Code a name animation 1. Okay, and let's go over here and run this. And there's a sphere. It automatically makes a sphere. It's at the origin. You can't see it's not very well centered right now. And there you go. Its radius is 1 because we didn't say otherwise, and it's white because we didn't say otherwise. Now, if we want to make a sphere that is at some place besides 0, 0, 0, besides the origin, and inside of the sphere function that creates this object, that creates this visual sphere, we need to set up the position. POS stands for position. So we want to set the position equals something. And you can type in the numbers, say 5.5. But that by itself is not enough, because in GlowScript the position is not just a set of coordinates, it is an actual vector object. An actual something, so to speak, pointing from the origin to where we want the sphere to be located. So in front of this set of three numbers we have to type VEC for vector. Now if we run it, it's off to the side. Okay, so we can create a sphere. We can do things like change colors, and we'll do those enhancements later after we get the basics. We want to make the sphere move. Okay. So to make a sphere move, we need to change the position. So I put the cursor at the end of line 3, and I put a blank line in here. And we want to change the position, maybe change it, say, to 1, 1, 0. And the way you change an attribute of an object, in this case position, type. Well, I haven't really given the object a name yet. A sphere is not really the name of this particular object. It is simply a generic object. So first, if I want to have a sphere that I can move, I need to give this particular sphere a name. So I'll type ball equals. Now the word ball is the name of this particular sphere. Sphere is a sort of generic object, and ball is this particular sphere. So to change the position of the sphere that I've named ball, I type the name of the sphere, ball, period, and and the attribute I want to change, which is POS for position. And say I want to change it to, I have to use vec for vector 110. Okay. Well, it happened kind of quickly. We couldn't really see what was happening. So let's put a little statement in here in between two on that back blank line I created, line 4. So we're going to tell it to stop for, I don't know, a quarter of a second. 0.25 sleep function, and that's inside the parentheses. It will sleep for 0.25 seconds. The program will just take a break for 0.25 seconds, and then we should be able to see the motion. Save early and often up here. Run it. Okay, so we saw the motion. I'm going to run that again. And if you look at it closely, you'll notice it looks like the sphere is getting smaller. Now in GlowScript, as you do something, you're looking at the XY plane. So since I'm only moving on the XY plane, it should stay the same size. The reason is that as you're moving objects around, creating objects, GlowScript will automatically move the camera back so everything stays in the field of view. So if you don't want that to happen, on line 2, I'll hit enter a couple times so I've got some space here. We want to be able to change an attribute of the overall scene. So type scene dot. We want to change what's called the range. Range is basically the size of the scene. And let's set that to 1.5. That way we've got plenty of space. So that's one thing that'll change it. The other thing is to help things fit a little better. We can change the size of this ball, the size of this sphere. So inside of the line that's creating the sphere, after pos equals vec 0.5.50, type a comma, and set the radius of the sphere. So let's set it to 0.2, 0.25. So now it is not changing size. It's getting a little warped a little because of our angle of view. So maybe I'll change this range to 2. So again, you should be trying these things out, seeing how it works. Maybe try a couple different things. Okay, so save often. Okay, and we can see the ball move. Now, this isn't quite a smooth animation because we actually see the ball moving. It jumps from one place to another, and it's a bit of a glaring jump. For a good smooth animation, you want the time to maybe be about 0.03 seconds. And that happens very, very fast. It does not look like a ball smoothly going from one place to another. The reason is it's moving much too far at once. We need the change for each motion of the ball to be small enough that it looks smooth. So there's a couple things we'll do to make the animation a little smoother. One of them is, instead of just jumping from one position to another, we're going to instead put a cursor at the end of line 6, hit enter a couple times. Instead, we're going to talk about changing the position. Change a position equals, since position is a vector, its change has to be a vector. We want the position to change by something small, so we don't really see it jumping a lot. So maybe have it change by, say, 0.02. Okay, so that is the change of position. It's going to change by a little amount. So now, instead of saying what the position is in line 10, we want to say that the position is the position plus the change. Okay, mathematically this is ridiculous because you're saying something equals something plus something is the same thing on both sides. That's mathematically ridiculous. But in computer, on the right, it's taking the current position of the ball, it's adding something to it, so it's changing the position, and then it's putting that number back into the position of the ball. So the number position of the ball effectively is being changed by this amount, change position. One way of looking at it, remember the ampersand, the hashtag mark as a comment, is that the new position equals the old position plus change of position. Okay, so we can do this, and we are actually changing the position of the ball. But it was very small. We can pretty much see it. It looks a little smoother than it did before. But we're still not seeing that smooth motion. So what we really want to do is to take this little sleep, I'm going to copy it and put it on line 13. And I'm going to take the change of the ball changing position and copy that. And we're going to now do 2 iterations of changing the position. Okay, so that looks a little better. It's starting to look like something is moving. But it's not moving very far. So I'm going to start the ball a little closer to the origin. I'm going to make the ball a little bit smaller. And basically, to have a good animation, we need to do this lots more times. Okay, so basically, I want to take the set of 2 lines, copy them, put the cursor at the end, hit enter, and paste them. So we'll keep doing this. And do this maybe 10 times so we can see about a fraction of a second and see the ball smoothly moving. So pause the video and go through this until you've done this 10 times. I will stop recording and do it, and then you can see if what you have looks like what I have. Okay, so copy and paste. I now have the same set of lines 10 times, so we'll go through that 10 times. Save it so I don't lose my hard work. And that's looking a little better. It's maybe a little jumpy. We should maybe... No, that's not too bad. If we had it move a little smaller distance, it maybe would look just a little bit better. But if we're moving a smaller distance, we would have to do this more times to be able to see it move on the screen. That could get tedious. We would have to do this not 10 times, maybe 30, or for motion that lasts a few seconds to simulate it, we'd have to do maybe 100, maybe 1,000 times, and that's going to get a bit tedious. So in the next video, we will see how to avoid the tedium of the copying and pasting needed to do it this way. If you've seen computers before, you're probably saying, well, why did we do it this way to start with? But if you haven't seen computers before, you're now seeing that, well, it could get a little tedious to do it this way, and we will see a way that is better.